Elon Musk's dream of colonizing Mars is one of the most audacious goals in modern space exploration. This vision, stemming from a deep-seated desire to ensure humanity's survival, has become a cornerstone of Musk's work with SpaceX. From the early days of sending greenhouses to the red planet to inspire earthly audiences, his ambition has grown into a fully fledged plan to build a city on Mars. Musk believes that multiple planets will safeguard human life against potential catastrophes on Earth. In the 1970s, scientific literature began exploring the idea of Mars colonization. However, it was Musk's passion and resources that turned it into a tangible goal. His vision is more than scientific curiosity, it's about creating a backup for humanity. Musk often describes Mars as a fixer-upper of a planet, emphasizing the challenges ahead but also the potential for transformation. His approach is both pragmatic and visionary, combining immediate technological hurdles with long-term aspirations. SpaceX, founded in 2002, became the vehicle for this grand endeavor. The company's mission is to make space travel cost-effective and sustainable. Early projects focused on reducing launch costs, culminating in the development of the Falcon rockets. Yet Mars was always the ultimate goal. Musk's charismatic leadership and relentless pursuit of innovation have inspired a new generation of space enthusiasts and potential explorers. As humanity looks to the stars, Musk's plans offer a roadmap to interplanetary species. The journey to Mars is not just about technology, it's a story of human ambition, resilience, and the relentless pursuit of what lies beyond. This first section sets the stage for understanding how one man's vision could redefine our place in the universe. SpaceX has transformed from a small startup into a leader in the aerospace industry. Central to its success is the Starship rocket, designed specifically for the Mars mission. Starship represents a significant leap in space vehicle design, combining reusability with the capacity to carry large payloads. The evolution of this rocket from concept to reality has been marked by numerous tests, setbacks, and breakthroughs. Initially, SpaceX focused on the development of the Falcon series, which provided valuable insights into rocket reusability. The Falcon 9 and Falcon Heavy rockets were stepping stones demonstrating the feasibility of landing rockets propulsively. These successes laid the groundwork for Starship, which would need to be even more robust and versatile for the demands of interplanetary travel. Starship's development has been a testament to SpaceX's iterative design philosophy, marked by rapid prototyping and continuous improvement. The Starship rocket is paired with the Super Heavy booster, a massive first stage designed to propel the spacecraft out of Earth's atmosphere. Together, they form the most powerful launch system ever conceived, capable of sending over 100 tons of cargo to Mars. This is crucial for transporting the infrastructure needed to establish a sustainable presence on the planet, from habitats and research facilities to food production systems. The goal is not just to visit Mars, but to live there permanently. SpaceX's work on Starship highlights the company's innovative spirit and willingness to push the boundaries of what's possible. By focusing on reusability and scalability, SpaceX aims to make Mars colonization economically viable. The evolution of the Starship rocket underscores the blend of technical prowess and visionary thinking that defines Musk's approach to space exploration. The Starship and its companion, the Super Heavy rocket, are at the heart of Musk's Mars mission. These two components form a launch system of unprecedented scale and capability. Starship itself is a fully reusable spacecraft, designed for long-duration spaceflights and capable of carrying both crew and cargo. Its stainless steel construction is not only durable but also reflective, helping to manage temperatures during re-entry. The Super Heavy booster is equally impressive. Standing at over 70 meters tall, it provides the necessary thrust to break free from Earth's gravitational pull. Once its job is done, the booster returns to Earth for reuse, landing back at the launch site or on an offshore platform. This reusability is key to keeping costs down and making space travel more accessible. SpaceX's focus on rapid turnaround between launches aims to achieve a cadence that supports frequent missions to Mars. A critical feature of Starship is its ability to refuel in space. On-orbit refueling is essential for the long journey to Mars, as it allows the spacecraft to reach its destination with the necessary supplies and return safely. This process involves docking with a tanker spacecraft, a maneuver that requires precision and reliability. The technology for on-orbit refueling is still in development, but successful demonstrations will be a significant milestone for SpaceX. The technological sophistication of Starship and Super Heavy exemplifies the ambitious nature of Musk's Mars plans. By focusing on reusability, refueling, and scalability, SpaceX is developing the tools necessary to make interplanetary travel a reality. These innovations are not just about reaching Mars, they represent a leap forward in our ability to explore and inhabit the solar system. In situ resource utilization, or ISRU, is a cornerstone of Musk's Mars strategy. The concept involves using Martian resources to support human life and facilitate return journeys. This could include extracting water from ice deposits and converting carbon dioxide from the atmosphere into rocket propellant. ISRU reduces dependence on Earth-supplied materials, making Mars missions more sustainable and cost-effective. The harsh Martian environment presents numerous challenges for ISRU. Temperatures can plummet to extreme lows and dust storms can last for weeks, potentially disrupting operations. Nevertheless, the potential benefits make ISRU an attractive solution. Water, for instance, can be split into hydrogen and oxygen, providing breathable air and fuel. SpaceX is developing the technology needed to perform these tasks reliably in the Martian context. On-orbit refueling is another critical component of the Mars mission. This process allows spacecraft to carry heavier payloads by refueling in space, rather than carrying all the fuel from Earth. The logistics of on-orbit refueling involve complex maneuvers and precise timing. SpaceX has been testing various methods for fuel transfer in space, aiming to perfect this technology before the first crewed mission. These technological hurdles require innovative solutions and robust engineering. Overcoming them is essential for the success of the Mars mission. The development of ISRU and on-orbit refueling represents a significant step forward in space exploration, paving the way for sustainable human presence on Mars and beyond. Section 5. Timeline for Mars missions, uncrewed and crewed. The planned timeline for Mars missions reflects the complexity and ambition of Musk's vision. SpaceX aims to launch 5 uncrewed Starship missions to Mars by 2026. These missions will test landing capabilities, resource extraction technologies, and other critical systems needed for human habitation. The timing coincides with the optimal Earth-Mars transfer window, minimizing travel time and fuel consumption. Following these uncrewed missions, the first crewed mission is tentatively scheduled for around 2028 to 2030. This phase will focus on establishing the foundational infrastructure needed for a sustainable presence on Mars. Key objectives include setting up a propellant production plant, building initial habitats, and deploying power systems. These efforts are crucial for supporting subsequent missions and expanding the Martian settlement. The timeline is ambitious, and SpaceX acknowledges that delays are possible. The success of the uncrewed missions will be a decisive factor in determining the schedule for crewed flights. Each mission builds on the last, gradually increasing the complexity and scale of operations on Mars. SpaceX's approach involves learning from each step, adapting strategies and refining technologies based on real-world data. As SpaceX progresses through this timeline, the world watches with anticipation. The journey to Mars is fraught with challenges, but it also holds the promise of new frontiers and opportunities. The planned timeline reflects a methodical yet bold approach to achieving what many once thought impossible, establishing a human presence on another planet. Section 6. Navigating technological and financial hurdles. The road to Mars is paved with significant technological and financial challenges. Developing the necessary technologies such as reliable life support systems and radiation shielding requires extensive research and innovation. Starship's design, while revolutionary, must prove its reliability through rigorous testing. Ensuring the safety of crewed missions is paramount, demanding advancements in spacecraft systems and interplanetary navigation. Financing the Mars mission is another daunting task. The costs associated with developing, launching, and maintaining a fleet of Starships are astronomical. Elon Musk has consistently highlighted the need for reducing launch costs to make Mars missions viable. SpaceX's focus on reusability is key to achieving this, but additional funding sources are essential. Collaborations with governments, private enterprises, and international space agencies could provide the necessary financial support. The sheer scale of the Mars project also presents logistical challenges. Coordinating thousands of components, systems, and personnel across multiple continents requires meticulous planning and execution. SpaceX must manage these complexities while maintaining flexibility to adapt to unforeseen issues. The company's culture of rapid iteration and problem-solving is well-suited to addressing these hurdles, but sustained effort over decades will be required. Despite these challenges, the potential rewards are immense. Success would mark a new era in human history, expanding our presence beyond Earth. The journey to Mars is a test of human ingenuity, cooperation, and determination. By overcoming these hurdles, humanity can achieve what was once the realm of science fiction, living and thriving on another world. Section 7. Ethical considerations in Mars colonization. Colonizing Mars raises profound ethical questions that must be addressed. The potential impact on the Martian environment is a significant concern. Mars is a pristine world, untouched by human activity, and any colonization efforts could alter its natural state. Scientists and ethicists debate the moral implications of transforming another planet, weighing the benefits of exploration against the need to preserve extraterrestrial ecosystems. Another ethical consideration is the risk to human life. Mars is an inhospitable environment with extreme cold, high radiation levels, and a lack of breathable air. Ensuring the safety and well-being of astronauts is a top priority, requiring robust life support systems and medical facilities. The psychological impact of long-term isolation and confinement must also be considered, as settlers will face challenges unlike any experienced on Earth. The social and political aspects of Mars colonization are equally complex. Establishing a society on Mars involves creating governance structures, laws, and economic systems from scratch. These decisions will shape the future of Martian society and influence the dynamics between Earth and Mars. Questions about who gets to go to Mars, how resources are allocated, and who holds decision-making power are critical for ensuring a fair and just settlement. Addressing these ethical considerations requires global dialogue and cooperation. As humanity takes its first steps toward becoming a multi-planetary species, the choices we make will have lasting implications. By fostering thoughtful discussions and inclusive decision-making processes, we can navigate the ethical challenges of Mars colonization and honor our responsibility as stewards of the solar system. Section 8. Scientific opportunities and discoveries. Mars offers a wealth of scientific opportunities that could reshape our understanding of the universe. The planet's geology, climate, and potential for past or present life are of immense interest to scientists. Exploring Mars could reveal insights into the planet's history, including how it lost its atmosphere and water. These findings could inform our understanding of Earth's own climate and geological processes. The search for life on Mars is one of the most compelling scientific pursuits. Evidence of microbial life on Mars would be a groundbreaking discovery, challenging our understanding of life's origins and distribution in the universe. Even if life is not found, studying Mars's environment can help scientists learn about the conditions necessary for life to thrive. This knowledge is crucial as we continue to search for life beyond our solar system. Mars also serves as a natural laboratory for studying planetary science and astrobiology. Its diverse landscapes, including volcanoes, canyons, and polar ice caps, provide clues about the processes that have shaped the planet over billions of years. By analyzing these features, scientists can compare them to similar structures on Earth, deepening our understanding of planetary evolution. The potential for scientific discoveries on Mars extends beyond immediate research. By establishing a human presence, we can conduct long-term experiments and investigations that are impossible with robotic missions alone. Mars exploration has the power to answer fundamental questions about life, the universe, and our place within it, marking a new chapter in human curiosity and discovery. Section 9. Conclusion: the dream of a self-sustaining colony. Elon Musk's vision of a self-sustaining colony on Mars by 2050 is as bold as it is transformative. This dream involves not only technological advancements but also a reimagining of what it means to be human. The prospect of living on Mars challenges our notions of home, community, and identity, inviting us to consider new ways of life on a distant world. Achieving a self-sustaining colony requires overcoming significant hurdles, from technological and financial to ethical and logistical. Yet the potential rewards justify the effort. A thriving Martian settlement would not only secure humanity's future, but also serve as a catalyst for innovation and scientific discovery. It would inspire generations to pursue careers in science, technology, and space exploration, driving progress across multiple fields. The journey to Mars is a testament to human ingenuity and ambition. It represents our desire to explore, to learn, and to push the boundaries of what is possible. By uniting around a common goal, humanity can achieve feats that once seemed unimaginable. The dream of a self-sustaining colony on Mars embodies our collective hope for a future where we are not bound by our planet, but free to explore the cosmos. As we stand on the brink of this new era, the possibilities are endless. The dream of Mars is not just about exploration, it's about building a future where humanity thrives across worlds, guided by the spirit of discovery and the pursuit of knowledge. This vision, championed by Elon Musk and SpaceX, invites us all to look beyond the stars and imagine what lies ahead.